Okay, yesterday's lab was somewhat difficult in that you had to spend a lot of time understanding how to break down the uh, compounds into their ions and then reforming them. This is all of these were called what double replacement reactions, and we'll deal with that later on in the semester. But just as a reminder about how things work, remember we started with aluminum sulfate. I'm sorry, nitrate. Let's get that right. Nitrate. And you were asked to turn that into a compound, write the formula. So you should have done aluminum NO3, 3, because aluminum is a 3 plus. And our nitrate ion is a 1 minus. And then up above we had sodium carbonate. And again, I'm just going to use shorthand because you should have already done this. And you were asked to also put that into formula, and that should have been Na2CO3, because Na is a 1 plus, being in group 1, and our carbonate ion is a 2 minus. Okay? Now, here's where in lab you were asked to figure out if there was a precipitate forming. And remember, a precipitate is a solid that forms when you add two liquids together. And when you added the two liquids, the aluminum nitrate and the sodium carbonate together, the drops on the piece of paper, then you found out that there was sort of a milky white substance that formed. Now, part of lecture yesterday, I told you that the nitrate and the sodium are soluble in water, which means that they will not precipitate out. So if those won't precipitate out, then the only two things that can precipitate out would be the aluminum and the carbonate. Okay? So that means if you got a precipitate, you would have taken the aluminum, which is a 3 plus, and the carbonate, which is a 2 minus. Oops. And that would have been the precipitate that was formed. So knowing what the charges are, and remember you want to do a reverse crisscross, a crisscross, okay? And one of the reminders I need to make right here, because a lot of you I was watching yesterday, remember that you cannot separate out any part of the carbonate ion. It needs to stay intact. So the carbon, the oxygen, and the subscript all need to stay together when you do your crisscross, which is why you have to put them in parentheses. So your final compound should look something like this. Al2 parentheses CO3 close parentheses sub 3. Okay, and that's, you would have written out aluminum, carbonate. Okay, so that's for the first square. Now, every one of them down the line, during that first line, with the aluminum nitrate and going down in this direction, down this way, and all the way across this way, okay, all of these with the sodium carbonate would have formed a precipitate with the aluminum. So when you look at the original compounds that you're dealing with, remember, it's this cation with this anion. Once again, this cation with this anion. Now, why is that? Because as I mentioned before, Sodium is soluble in water, so that won't precipitate out. And nitrate is soluble in water, so that won't precipitate out. So that leaves us with aluminum 2 carbonate with as our compound. Okay. Now, once again, if you were to use stock system for this, just one more piece of information before I leave you to do the rest of the lab for yourself. If you were to write this out with stock system, it would be aluminum 3, Roman numeral 3. Why Roman numeral 3? Well, because aluminum has a 3+ charge as an ion, and then carbonate. Okay? So, go about the rest of this. Remember, every compound that precipitates, you need to write a formula and a name for it. And maybe for extra credit, if you understand the stock system, go ahead and write an additional naming using the stock system. Okay? All right, good luck, guys.